For my second attempt at standard 1.2, I chose to do problem 1.11 from our textbook, and it asks us to consider a beam of spin 1/2 particles that are prepared in this state. So part A asks us what are the possible results of a measurement of the spin component S sub z, and with what probabilities would they occur. So first, we want to check to make sure our quantum state has been properly normalized. So let's first do this by writing our quantum state in matrix representation. So that's shown here. Now to normalize, we'll introduce an overall complex multiplicative factor we'll call C and solve for this factor by imposing the normalization condition. That is shown here. And then we can plug in for our quantum state, and we have this. So this is the complex conjugate of the ket we have here. And we multiply that through, and we solve for C, and we find that C is equal to 1. So since we know that C is equal to 1, we know that our quantum state is already normalized. The possible results for a 1/2 spin particle beam measured along the z-axis is either spin up or spin down, so plus or minus h bar over 2. The probability of measuring SC equals plus h bar over 2 is shown here, and we find that that is equal to 9 over 34, and we get this definition right out of our textbook, and we're just basically taking the state that we find that we are measuring and take it with the inner product of the input state, and we take the inner product of those two and take the modulus squared, and that gives us the probability. And then the probability of measuring S equals minus h bar over 2 is here. And we find that that is equal to 25 over 34. And both these probabilities add together equal 1. So that's a good way to check to make sure that we found the right probabilities. Because if they are more or less than 1, then that wouldn't make a whole lot of sense, since there's only two possible outcomes, either spin up or spin down. Suppose that the SC measurement yields the result SC equals minus h bar over 2. Subsequent to that result, a second measurement is performed to measure the spin component S sub x. What are the possible results of that measurement, and with what probabilities would they occur? To understand this problem, it is helpful to look at the fifth postulate of quantum mechanics from our textbook. It tells us that after a measurement of A that yields some result A sub n, the quantum system is in a new state, which is the normalized projection of the original system ket onto the kets corresponding to the result of the measurement. In part B, it tells us that the SC measurement yields the result SC equals minus h bar over 2. So from this, we know that our new state has to be just spin down on the z-axis. So this is what our new state will look like. From this, we can calculate the probabilities. For a measurement of S of x equals plus h bar over 2, the probability is this. So our ket is our incoming state, and then here is the probability that we are measurement, so that's our bra. That's spin up on the in the x direction. So we take the inner product of those two and take the modulus squared of that, and we find that it's equal to 1/2. And then the same thing for minus h bar over 2. So here is our incoming state, and here is the state that we are measuring. And we find that it's also equal to 1/2. And again, both those probabilities add up to 1. So part C asks us to draw a schematic diagram depicting the successive measurements in part A and part B. And I have that shown here. So here is our incoming quantum state, and going through a Stern-Gerlach detector, and we found that spin up for part A was measured along the z-axis is 9/34, which is about 26%. And then for spin down, it's 74%. And then part B, we have our incoming state, which is just spin down along the z-axis, and we found that measuring spin up and spin down on the x-axis yields a 50% chance for both. So this is my second attempt at Stinger 1.2.